will point to the next instruction, right, or to the next address where the next value can be inserted into the stack. So these are the two main things that we need to implement in here, right? You can think about how pop will work, because I will leave the pop machine instruction entirely onto you. So now let's do this. So we'll modify micro instructions, right? So because we need to increment the stack pointer register, I need to include a micro instruction that will increment the stack pointer register. So that is SPR, and we want to increment, right? The delta here would be 2 in that case, because we will be incrementing in multiples of 2, right? So this is increment. And then the next one that we have in here is, so once I'm done with that, then I need to include micro instructions that will write to the stack memory, and that is the memory access micro instruction. So as you can see that we currently have two micro instructions in here. One is this one is reading from the main memory. This is writing from the main writing to the main memory. So now we will include another one, and that is stack. So
Maru,
the address would be SPR, and then so this is writing in that case. So we have MDR transferring data to the stack at the address given by the stack pointer register, right? So MDR, this is just a name, and you can put any sensible name in that case. I'm doing write. Where are we writing? To the stack memory. Where is the data? Data will reside in the memory data register. Which address? It is the stack pointer register. So I have done that. This is only for the push operation. For pop operation, you need to include the micro instruction on the memory access. All right. So I'm done with this. Then the next thing that we'll be doing is we'll modify the machine instructions again. So we added the machine instruction, but we did not implement it. If you notice other machine instructions, it has been implemented here by adding the micro instructions. So we will be adding that. So this is the step that we'll follow. We'll transfer the data from the accumulator to MDR. So transfer register to register function, accumulator to MDR, I have inserted that. Then we'll transfer the data from the MDR to stack, that is memory access. From MDR to stack, you insert the value. Then we want to increment the stack pointer register. So you increment the stack pointer register, and then we end the implementation. Remember, every implementation of the machine instruction will basically finish when you put the end machine instruction there. So this is what you will be having in that case. Okay, so this is what we have. You click on OK. Now we have successfully implemented the machine instruction, which is the push machine instruction. Now we will write a small program. So I'm going to close this and open new text. We'll write a small program. Sorry, a new text. All right, we'll write a small program, and what the program basically will do, it will read 3 numbers, and this is a machine language, right? So read, and that's reading the first number, first num. Then I'm going to push it. As I have said, that there is no operand involved in there. Then you read the second one, which is second num, and then you push the value into the stack. Then you read the third number, which is third num, and you push the value onto the stack. So this is what we basically have as the program, and at the end you stop the program, right? So this is what we have as the program. Very simple one. I can't pop because I haven't implemented the pop machine instruction. Okay, so I'm going to save this. save text as, so it is a push program. Right. Then I'm going to execute it. So, right. So clear, assemble, load, and run. And now you should notice the contents of the register with the content of the stack here. So if I put in the value 1, so now you can see that the stack pointer register, which was initially pointing to 0, now it is pointing to address number 2, which is the second one here, right? So it is always pointing to the top of the stack, right? Not the top element of the stack, but to the top of the stack, okay, which is an empty space. And then you should also notice that value 1 has been pushed into the stack at location number 0. Then the next one that we have is we want to insert the value 2. So now the value 2 has been inserted into the stack, right? The stack pointer register has been changed and it is now pointing to location number 4. Then I want to insert the value 3. So when I insert the value 3, the stack pointer register points to value address number 6 in that case, and the value 3 is there. So now you can see that the 3 values that I entered through the keyboard has been pushed into the stack, right? And these are the 3 values that's available. So if I want to make a graphical structure for this, so this is what we have the stack as. So it is currently, it currently has these values, right? So the top of the stack is this. This is where we insert the data. This is the lowest value that we have in the stack. If you want to remove the value, so the first one should be removed. You pop the first one, then you pop the second one, then you pop the third one. Individual pop instructions will be needed to pop individual elements from the stack. It's not that you will use only one pop statement and it will pop the entire stack. No, right? So you need individual statements in that case. Of course, if you want to do it in a loop, then the story is different in that case. The loop will basically repeat the pop statement, but otherwise you need separate pop statements in that case. So this is what we have as the current structure. So I hope that you have understood the addition of the stack memory. How do we go about adding that? Also, you should have understood how I added the register in that case, and then how I executed the assembly language program earlier on. I described what the assembly language program basically does and how to go about executing it. Then the other thing that we did is we added the machine instruction, which is only for push machine instruction, and we implemented the push machine instruction by implementing or writing the micro instructions in that case. So that is what we have done so far. But the assignment number 2 does not end at this particular point. The assignment will require you to write or insert the call and retain machine instruction. Now I would say that the call and the retain machine instruction will be just the difference in terms of names. Otherwise, the implementation of the call and retain machine instruction will be same as the jump machine instruction, which is of code number 9. So you can actually include that. Now I will share with you a sample program, which is just give me one moment. Okay, so I hope that you can see a sample program here. So the call and return machine instructions are basically used in this particular program. So this question says, write a complete Wombat 3 assembly language main program and subprogram. The main program tests the subprogram. It reads in exactly one integer, checks that the integer is valid input, calls the subprogram and writes out the result. The subprogram computes the function, which is given as f of n is equals to 4 times n times f of n minus 1, where f of 0 is equals to 3. The program must be properly commented in that case. This is the part of the question that we have. So I would like to first differentiate between the main program and the subprogram. So this is what we have as the main program. So this is the main program in this. Okay, so that's the main program, and the remaining that we have, it can be said that it's a subprogram. So that is a subprogram. The requirement of the subprogram is given. The requirement of the main program is given. It says the main program tests the subprogram. It reads in exactly one integer. That is what it does. It reads the integer, checks that the integer is valid input. So it checks because we do not want any negative value, right? So that is why it's checking whether the value is negative or not. If it is negative, then it will again jump back to instruction number 1 and you read the positive value, right? Then it calls the subprogram and writes out the result. So now you can see it pushes the value onto the stack. So stack is used in this communication for parameter passing. Okay, so stack is used. So whatever value that we read in, it is placed onto the stack. Then you call the subprogram. So this is where the subprogram starts. Now we leave the main program and we go onto the subprogram. From there, we come into this particular location. So then you pop the value, you compute whatever results. At the end, you push the value onto the stack. That means the value that you have calculated, you will push it onto the stack, and then the main program, then you return to the main program. So this is where you return to the main program and you pop the value right and you stop the program. So this is what you basically have in there, right? So now you can see in this case the usage of the push and pop machine instruction. You can also see the usage of the call and return machine instructions, right? So this actually explains the second objective, or the second part of the first objective, which is call and return machine instruction. It also shows you an example of a machine or assembly language program here. All right. So this particular document will be uploaded on Moodle, and this particular session has been recorded. I will contact the ITS as to how it will be uploaded on Moodle, right? But the session has been recorded, right? You will be notified via Moodle on the recording of this particular session. Otherwise, that is all from my side. This was only for the assignment number 2 discussion, while other things regarding the course, Mr. Emmanuel Reddy will be discussing it with you. So you are supposed to have a look at the pre-recorded lectures for every week. Make sure that you go by the topics. So this week was the instruction set architecture level. Make sure that you have a look at the recordings that discusses the instruction set architecture levels, right? And then, of course, Mr. Emmanuel Reddy will summarize the topics at the end of every week, and he will also guide you on how to go about looking at tutorial questions, which videos to basically look